And we did lesson 5 of unit 6, and it's called Building Quadratic Functions to Describe Situations, Part 1. And then the rest of the week, we're doing the Part 2, Part 3. So it's really just this whole week talking about real life situations involving quadratics. Now, your introduction to quadratics was last week. Let's see what we can remember of those functions. Just like the other two that we learned, there's like some characteristics about quadratic functions that you need to know. Can you tell me any of them? Maybe like what the graph looks like, what the equation is. Exponential is a different type of function. Quadratic is its own type. I think in lesson 3 or 4, you guys compared them to exponential functions. So that you should have learned that which one always grows the fastest. Exponential always grows the fastest. Quadratics, what do those graphs look like? Or what? A U shape. So it's either up like a smile or down like a frown. No like sideways U shapes. It's one or the other. Does anyone know the equation for quadratic functions? So just like how linear has its own equation, exponential has its own equation. What's the equation for quadratics? Y equals x squared is our most basic quadratic you can have. That x squared makes the U shape. So if you have something higher than a square, like, I don't know, x cubed or x to the 4th, that's not a quadratic. It would have to be x squared is the highest exponent, and the x is no longer the exponent, okay? It's x squared, and there could be other things, like later on you'll see where there's x squared plus x, or x squared plus 4, or x squared plus x plus 4, but the very basic parent function is x squared, makes our quadratic. So that you learned while I was not here, so good job on learning it if you really did the lesson and practice yourself. But this week, it's more like the real life situation. Now, can you think of a real life situation, and we're talking about falling objects right now, where we drop something and then it goes back up? Does that usually happen where we drop something and then it goes back up? So then it's not necessarily going to be this type of quadratic. It's going to be more so this type. Because this could be like you throwing a ball and someone catching it, or you dropping something off a building was like what we talked about today. So if I drop something off the building, it follows more of a pattern like this, but maybe more like half of the U. Okay, so that's why we're doing it. If I could summarize today's lesson in a way that's like taught more directly instead of making you figure it out yourself, I would tell you that in any situation where we're talking about projectile motion, so I need you all to listen, you need all to now look at your screens, even if it's not, I need you all to listen. But any situation where it's projectile motion, something being thrown, something being dropped, you could use this setup. And I didn't necessarily explicitly say it in class, so if you want to write it down, I think that'd be a good idea. But it's negative 16x squared plus vx plus s. The negative 16 is hopefully familiar from today's lesson. That has something to do with gravity. Okay, so I mean, I'm not a physics teacher. That has something to do with gravity. That the more something is in the air that's falling, the faster it falls. Gravity pulls on it. So that negative 16 is always there, attached to the x squared. The v would be velocity. That would go in front of the x. And because obviously if I throw something off the building versus just dropping it, like that's gonna have different speeds. So velocity would, if it mentions it, would go in front of the X. And S would be for starting height. So if it says it was thrown off a building of 500 feet, you would expect the 500 to be in your equation. And it would be the constant, like not attached to the variable. Okay, questions, comments, concerns? That might help you with some of the problems on there. Okay. But otherwise, in the lesson, we mostly just use tables, graphs, and equations to represent it. This formula gives you where X is time, usually in seconds, because it doesn't take a very long time for something to fall. And Y would be like your height. Okay, so that I'm gonna leave because we took some really good notes up here. I'm gonna leave this up on the screen. What you are going to work on now and try to get 80% or higher on without cheating, and without like, I don't know, just guessing, is a 6.5 practice. So work on that. Last 30 minutes, so maybe, because that'd be 10 minutes from now. So maybe in 15 minutes, I'll do whatever you want to see on the screen, and it could be from any like unit 6 homework since it's been a few days. But since you're all here today, holding you all accountable to the lesson 5 practice. Questions on that? Okay, I think I just need to enable it for Brooklyn, and then everyone else will be already enabled.
With number 4, then that's on the screen. Okay, so you had to determine whether 5n squared or 3 to the n will have a greater value when n equals 1, 3, and 5. So what I would suggest to keep it all organized is make a table for both. Looks like n is our input. And then 5n squared for the output. And then we'll do 3 to the n for the other output. So the n values that we're testing are 1, 3, and 5. For each situation, you are plugging in n into the expression and then seeing what the calculator tells you. Whenever you plug stuff in, especially now that we're moving into quadratics, you really need to make sure that you're using parentheses. Because if these were negative numbers and then you didn't put parentheses but tried to square it, it would give you the wrong answer. You should never square something and get a negative. Maybe if you multiply by a negative after that, you could, but just use parentheses each time. And I would suggest put it all in the calculator at once. If you try to break it apart, make sure that you do exponents first. I won't use a calculator because the numbers aren't that bad, but highly recommend just use them. So exponents you do first. 1 squared is, and then 1 times 5 is, and then next we're plugging in a 3 into that expression, seeing what we get. 3 squared is, 9 times 5 is, and then 5 squared is, and then 25 times 5 is 125. Sounds right. Yes, I think so. Someone can correct me with the calculator. But yeah, so you plug it in. You need a table to organize it, but that's how we're getting the values in the table. And then we're also plugging in 1, 3, and 5 for the other expression. This time the variable goes in the exponent spot. So what's 3 to the first power? 3 to the third power. Not 9. 27, good, because it's 3 times 3 times 3. And then 3 to the 5th power, that one I do need my calculator for. I got 243. And someone can Okay, good. So we got all the values, that's, you have to calculate the input or the output when the input is these numbers, and now we're comparing. So to kind of shorten it, I'm gonna call this one the quadratic because that's what it is. It has a variable squared, that makes it quadratic. I'm gonna call this one the exponential because that's what it is. The variable itself is the exponent. Hopefully you notice that too. But when n is 1, which is greater, the quadratic or the exponential? Like the 5n squared then. When it's 3, which one's greater? Quadratic still. And when it's 5, what's greater? So in that one lesson, I want to say lesson 4, it had you comparing something like this. And you notice that the exponential always like will outgrow the other one. It might start out lower, but at some point it always like grows fastest. Questions on that? Questions on others from any unit 6 practice? Jaden? Number 2. Number 2 on this one. Yes. Okay. So number 2, if you guys also needed help on today's, was a baseball travels d meters t seconds after being dropped from the top of the building. The distance traveled by the baseball can be modeled by this equation. First, you need to complete a table of values. You will have something just like this on your unit test. So you have to know, like, when it gives you an equation, usually they'll put the variables there to help you. But if these are t's, then I need to plug them in where the t goes. If it gives me d's and I need to find the t, then you plug in for the value of d and then solve for t. But for the most part, it was just you computing your inputs is what I saw on your test. So in each of these, I'm plugging in for t. So first I'll have 5 times 0 squared, then 5 times 0.5 squared, 5 times 1 squared, like do you see, like we're just plugging in. And again, I'd make sure anytime you plug in, use parentheses. This time I'll show you on the calculator because that's what I would recommend you use, even if the problem's easy. It'll just be more accurate. Okay, so 5 times 0 squared is 0. And then I'm just going to change the input each time. When the input's 0.5, my output's 1.25. When it's 1, my output's 5. When it's 1.5, my output's 11.25. I wouldn't round or anything, it doesn't say to. And these are not long decimals, so just don't round unless it says to. So there's how I got all my inputs or outputs. Any questions? The next part says, is it traveling at a constant speed? So constant would be like a straight line when graphed. So would this give me a straight line when I graph it? No, and you could try actually graphing it, or you could just look at your outputs. From here to here, I added 1.25. From here to here, I added 3.75. Like, it's not constant. So you would put an N for no, but just put N. Questions there? Tiana? Now, other questions from any unit 6 practice. Well, remember, I'm holding you all to the 80% or higher for this one specifically. And when I do grade, and I know I'm behind, sorry. If you're an athlete and you're under grade check, just tell me, make sure to grade yours first. But when I grade, I do check like your attendance too. Like, I don't penalize you in math lab when you're absent for that lesson. Granted, you still need to make it up for algebra, but I'd rather not like penalize you twice. I know when you're absent, it takes you like twice as long to do the same assignments as if you were here. So I do check that. Since you're all here today, I'm holding you to the lesson 5 practice, 80% or higher. But all the other ones, we still want to get 80% or higher on when I go back and grade it. But any other questions right now? Don't be shy. You're going along. Yeah. On today's? Okay. All right, so a rocket is launched in the air. Its height in feet is modeled by function h. Here's the graph representing it. Select all that's true about the situation. So think like this following the real world situation. Looks like we have the rocket going up and then down. So don't overthink that part. When it says the rocket is launched from a height less than 20 feet above the ground, would you say that that's true? Yeah, if you see how it's counting, this is height, looks like it's counting each tick mark by 20. So we would say it's launched from a height less than 20 feet above the ground. It didn't start at 0, so it looks like it's above a little bit, but definitely less than 20. So then I wouldn't say about 20 because it doesn't look like it's touching the 20. I would definitely say less. The rocket reaches its maximum height after about 3 seconds. So like, where's my highest part of this? How would you describe that? 3,160 is the exact coordinate. See if that's like centered. I don't know if it's centered or not, but after about 3 seconds, do you think that that's accurate? I would agree. So 3 seconds is right here. That looks like its maximum height. The rocket reaches its maximum height after about 160 seconds. That would be you confusing your y-axis. That's the height. That's the maximum height, not time in seconds. And then lastly, the maximum height of the rocket is about 160 feet. Would you guys say that that's true? So then I would just go with those 3. And that's right according to you. So it can never be like both above and about 20 feet above the ground, or its maximum height is both 3 and 160, like it's one or the other. If you do pick a wrong answer on Schoology, it does like penalize you. So that might be why. Questions on anything else? Could be any unit 6 practice. I still need to disable the unit 5 practices, but hopefully no one's wasting their time.